Newton's first law. An object in motion will stay in motion unless acted upon by a net outside force.
Here is the golden snitch in motion. It is staying in motion because there is no net outside force acting on it.
Here we see that the snitch is stopped by Harry's mouth. It comes to a stop because Harry is a net outside force.
Newton's second law. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object.
This equation is force equals mass times acceleration. If Harry has a mass of 60 kilograms and he is accelerating at a speed of 10 meters per second squared, then the force of the broomstick on Harry is 600 newtons.
Newton's third law. For every action, there is an equal and opposite reaction.
Therefore, as I ran into the sled, as you can see here, the force of me on the sled is equal to the force of the sled on me.
We made a force diagram for the forces acting on Count Dooku's head in this situation.
There is a force of Earth on Dooku that is equal to the force of the ground acting on Dooku.
There is also a force of Yoda on Dooku going to the right.
In this situation, Darth Vader has constant velocity. To find its displacement, we use x final equals velocity times time plus x initial. We plugged in 6 seconds for the time and 2 meters per second for velocity. We did not include an initial position because he started at 0 meters. This gave us 12 meters for Darth Vader's displacement.
In this situation, Darth Vader has a non-constant velocity. In order to find his final velocity, we used final velocity equals initial velocity plus acceleration times time. We plugged in his initial velocity as 2 meters per second, his acceleration as 1 meters per second squared, and the time as 3 seconds. His final velocity was 5 meters per second.